MTH100 lesson 6.4 is factoring special forms. So we've already talked about factor by grouping. We've done factoring trinomials. And now let's talk about special forms. So the first thing we need to review is what exactly is a perfect square. If I take 1 and I square it, I get 1. If I take 2 and I square it, I get 4. And so on, if I keep going. So these numbers over here are all perfect squares. 1, 4, 9, 16, and that list goes on and on. That's what perfect squares are. So the first special form that we're going to look at is called the difference of squares. And when I say squares, they will be perfect squares. For example, if I had x squared minus 81. Now, this word difference means we are subtracting, okay? And squares means both of those numbers are perfect squares. X squared and 81 is a perfect square because that is 9 squared. So to factor the difference of squares, we have this little rule that says if you are subtracting two squares and we want to factor them, then we take the square root of each number. The square root of a squared is a. The square root of b squared is b. We put it in our parentheses twice. One parentheses gets a plus, the other parentheses gets a minus. So in the example above, if I am going to take the square root of each of them, the square root of x squared is x. The square root of 81 is 9. So that goes in both parentheses. One parentheses gets a plus, one gets a minus. So that would be our factors for that particular problem. So let's do another difference of squares. All right, so again, this is difference because it's subtracting. 36 and 25 are both perfect squares. So I take the square root of 36x squared and I get 6x. Goes in both parentheses. The square root of 25 is 5. One parentheses gets a plus, one gets a minus. So this only works on difference of squares. So this little rule right here only works on difference of squares. Let's do a few more. I have, let's change that from a square to let's make it a 10. The 10. All right, these are perfect squares, and it is the difference. So the square root of 25 is 5. The square root of 4y to the 10th is 2y to the 5th. Because remember, when we multiply, we add the exponents. So one parentheses gets a plus and one gets a minus. All right, now remember, if our directions tell us to factor, which in all of these so far we have been factoring, one reminder, when our directions tell us to factor, we always need to check and see, is there a greatest common factor? Now the last two I have not done that because we're just focusing on difference of squares. But if my directions say factor, I always look for greatest common factor first. In this case, there is one. 18 is my greatest common factor. So I'm going to factor it out. 72 divided by 18 is 4. 18 divided by 18 is 1. Okay, so I've taken care of my greatest common factor. And now I have to recognize that this is the difference of squares. So I need to factor that. I'm still going to keep that 18 sitting out front. And we're going to factor my difference of squares. The square root of 4 is 2. The square root of x squared is x. One gets a plus, and one gets a minus. So super important that that 18 is multiplied out front. And we always want to factor as far as we possibly can. Let's try another one. Okay, my directions again are factor completely. All right, so we always look for the greatest common factor. There is one here, our greatest common factor. Actually, there is not a number that goes into 18 and into 16. Sorry, 81 and 16. So there's not a greatest common factor. They are difference of squares. So that's something I'll have to recognize. So the square root of 81a to the 4th is 9a squared. Goes in both parentheses. The square root of 16 is 4. One gets a plus and one gets a minus. Now this is where a lot of people just stop and they go, oh yay, I did so good, which you did, this is good, but it's not finished because this right here is also the difference of squares. And this is what it means by factor completely. We have to keep factoring until we can't factor anymore. There is no rule for sum of squares. So this 9a squared plus 4 just comes down. Nothing I can do to that. But I can factor this 9a squared minus 4. The square root of 9a squared is 3a. The square root of 4 is 2. One gets a plus, one gets a minus. Now I have factored completely. And so all three of those would be my factors. All right. So not everything is going to be difference of squares. Let's just keep going. That was just one of our special forms. Our directions are still factored. All right, so we're going to go through all the little steps. First, we always look for greatest common factor. There's not one. There are 3 terms, which means it's a trinomial. So I'm going to do this little process where I say 2 numbers that multiply to be AC, they add up to be B. So I've got to know what are A, B, and C. This particular problem, A is 1, B is 14, and C is 49. So A times C is 49, and B is 14. I'm looking for 2 numbers that when I multiply them, I get 49, but when I add them, I get 14. So that would be 7 and 7. Now if you do grouping, that would be x squared plus 7x plus 7x plus 49. First term comes down, second term comes down. Split up into the factors that we found. That gives me the 7x and 7x, and then the last term comes down. So now we group. Our first group only has an x in common. We factor that out, and we get x plus 7. Our second group has a 7 in common. When I factor that out, I get an x plus 7. Notice my 2 groups both have this little x plus 7. So it gets factored out front, x plus 7, and I multiply by what is left. And the things that are left are this x plus 7. Now notice my answer says x plus 7 times x plus 7. So my math lab is going to want you to write that answer like x plus 7 squared, because that's what it means. So they call that a special form, but it's just because x plus 7 times x plus 7 is x plus 7 squared. All right, let's try another. Okay, let's do one that's got 2 variables. All right, and so our directions are factor. First, we're going to look for a greatest common factor. There is not one. So that's taken care of. It is a trinomial. So I'm looking for two things that multiply to be AC, two things that add to be B. So I need to know what are A, B, and C. All right, our A value is 4. Our B value is everything other than X, so that would be 12Y. And my C value is everything there, the end, so 9Y squared. So A times C is 36Y squared, and B is 12Y. Looking for two numbers so that when I multiply them, I get 36Y squared, but when I add them, I get 12. Okay, and those two numbers are 6Y and 6Y. Okay, so I'm going to do this one with fractions. I take my A value and I put it over one of the factors I found. Take my A value, put it over the other one I found. If you can simplify, you do, and in this case you can. 2 goes into 4 twice, 2 goes into 6 3 times. So that works for both of these. And then I read it top to bottom to find my factors. So my factors are 2 plus 3y times 2 plus 3y. Now, you could have done that grouping. You're still going to end up with the same thing. Notice these say exactly the same things. So we're going to rewrite it as 2 plus 3y squared. Okay, one little thing I did forget to do, common mistake, the top number always gets the x value. Okay, so I should have had an x here, and here, and here. Sorry, I did not intentionally mess that up. We always put a along with x over the factors. All right, so we've got difference of squares, and the next thing we're going to do is cubes. So let's talk about what it means to be a cube. Right, a cube would be like 1 cubed is 1, 2 cubed is 2 times 2 times 2, which is 8, 3 cubed is 3 times 3 times 3, which is 27, 4 cubed is 4 times 4 times 4, which is 64. Okay, so, and that goes on and on and on. All right. So all of these over here are considered cubes. 1, 8, 27, 64, they're considered cubes. So we have two rules this time. We have a rule for sum of cubes. We did not have a rule for sum of squares. And we also have a rule for difference of cubes. Now, this is one of those things that you're going to want to have beside you when you're working your homework, so that you can see these rules. All right, so the sum of cubes, you would have 2 cubes that are being added together. That's what sum means. And so to factor them, we always use this process. This always works every single time. So that's why you want to have this beside you to make sure you get it right. And for difference of cubes, here is our little formula rule, and it works every time. All right, so make sure you have those written down. We're going to do an example, and we're going to have to use them, so you need to make sure that you have them close by. I'll try to slide over and do an example so I can still see these. This A disappeared. All right. So let's start with a sum of cubes. X cubed plus 27. All right. So I need to know what are A and B. Now those are not coefficients. Okay, A and B are not coefficients. Our A value in this particular problem is X. Our B value here is not 27, because we need to think of this as what thing is being cubed to give me 27. Well, it's 3 cubed is 27. So my b value is 3. My a value is x, and my b value is 3. This is not a trinomial, so we're not talking coefficients here. We're using this little rule I have. All right, so now we're going to plug in a and b everywhere that they belong in this little rule beside it. So we plug in a plus b times a squared would be x squared minus a times b, so 3 times x would be 3x, plus b squared, so 3 squared is 9. So that would be my answer. All right, let's do a difference of cubes. Again, I first have to recognize that these are cubes, which that's sometimes a hard part. And so I've got to decide what is A and what is B. Well, if I rewrote this to say 2y cubed, okay, because 2 cubed is 8 and y cubed, minus 5 cubed. Now I can see my A and B values. Okay, there's my A value, there's my B value. So A is 2y and B is 5. Okay, and now I plug those into the rule over here where they belong. All right, so we start with A minus B times a squared is going to be 2y squared, which is 4y squared, plus a times b would be 10y, and then plus b squared would be 25. So this little idea of deciding what are a and b, boy, that's going to be super helpful, because then you can just plug them in where they belong. All right, so that is it for section 4. Section 5, we'll put it all together.